Our next trig video is we're going to explain the inverse sine and inverse cosine. Uh, First of all, here's a familiar graph of the sine function. It oscillates between -1 and 1, and a half cycle is pi. If this continued, we'd end up with one cycle at 2 pi. If we want to produce the inverse, we need to take a piece of this that passes a horizontal line test. So we take -pi/2 to pi/2. You can see that passes a horizontal line test. And you just simply switch the axes. It goes from -pi/2 to pi/2, so that's what the y-axis does. Y goes from -1 to 1, that's what x does. And you could perform a reflection in that line to produce the shape of the graph. That's why the concavity changes. So this is a graph of the inverse sine. First of all, the domain is -1 to 1. That's up here. The range is from -pi/2 to pi/2. That's on the y-axis. You can just copy this right into your homework packet. Nothing original. Watching the video, copy into the packet, you'll learn something. We don't have time to spend volumes of time on inverse trig because we would get to something else, but at least you can get a general introduction. The cosine graph starts up here, looks like this: one cycle, 2 pi, or 360. If you're using high school degrees. We take this slice to produce the inverse cosine. That passes a horizontal line test. At these points, 0, 1 becomes 1, 0. You can switch the coordinates. That's another way to do it. Pi/2, 0 becomes 0 pi/2. It's on the y-axis instead of the x-axis. Pi -1 becomes -1 pi. And likewise, you can draw line y equals x and take the mirror reflection. That can give you this shape. That's the inverse cosine. Domain -1 to 1. You can check these out on your calculator, by the way. Try finding the inverse sine or inverse cosine of a number outside of this. It will tell you domain error. Try to find the inverse cosine of 1.5, for instance. The range is 0 to pi. That's this 0, this pi. In degrees, it's 0 to 180. Those are the answers you get out of your calculator. You can take the inverse cosine. The solution is quadrant 1, quadrant 2. Solution here is quadrant 4, quadrant 1. So that's about all we're going to say about inverse trig functions. So this is, in your homework, it asks you to draw a graph. Draw it like this. And make sure this graph paper, use multiple squares to get to one. Don't draw me a tiny graph. Stretch it out so that you can see all the various properties of it. So that's it for inverse trig.